G'day again. Our last video in this series is on sketching. What am I doing? Sketching simultaneous. Sorry, it's been a long day. Kids been a nightmare. Sketching simultaneous inequations. Okay. Sketching simultaneous. So simultaneous means more than one inequations. So remember from the last video that we got, in an equation might be sketching in sort of half of the plane, or it might be sort of a dotted line going like that, and it might be sketching sort of on that side. What happens if you've got two of these guys running at the same time? So what happens? Firstly, sketch each inequality on the same axes, and two, the solution is where they overlap. In other words, wherever they overlap, if you drew these two equations on the same one, I'll do it in red. If I drew that on this equation here, got that, and I shaded it in like that. Okay, so that's drawing the two on the same one. What I'm looking for is where do they overlap. And where they overlap, if you see it, it's this dotted line here, and this solid line here, and everything in between there. That's where those two inequalities overlap. And that is where the solution space is between those two, where they overlap. I'll do that in a better example. Let's do it now. I think I might just do one example. See how time goes. Let's do y is greater than 2x plus 1. Okay, and we'll have x plus y is less than or equal to 2. Just keeping it simple for the minute. Okay, so let's do this again. It'll just be a quick little sketch. It's not going to be anything marvelous. Not doing it on grid paper. You should do it on graph paper. You should. I can't. Here we go. So what we need to do is sketch this one and then sketch this one. And what we want to do is see where they overlap. Okay. So y equals 2x plus 1 we'll cross at 1 here. 1, and let's go gradient of 2, so a rise 2 and a run of 1. So it's going to look straight up like that. And it's greater than 2x plus 1, so it's not equal to, so it would be a dotted line. So let's just do a dotted line there. It's going to look something like that. Now, which side is it on? Let's do a test point of 0, 0. 0 is greater than 0 plus 1. In other words, 0 is greater than 1. True or false? 0 is greater than 1. That is false. 1 is bigger than 0, not the other way around. So that is false. And so that means that point 0, 0 is not part of the solution. So therefore, this side is the solution to that first equation. Okay, so that's the red part. I'll do the next one in green. Okay, so that's that one. Let's have a look at this second one. X plus y is less than or equal to 2. What does the graph of x plus y equals 2 look like? Well, what would the x-intercept be? The x-intercept is when y is equal to 0, so you have x equals 2. So you'll have this point here, 2, where it's going to be the x-intercept. What will the y-intercept be? The y-intercept is when x is equal to 0. So when x is equal to 0, y equals 2. So we'll have the point 2 up here. And it's equal, these are equal, so less than or equal to, so it's a solid line. So let me just draw my solid line through like that. Very good. And let's just figure out which side. Is it this side over here, or is it this side down here? Again, let's choose the test point 0, 0. Let's see if it's true or false. 0, 0, 0 plus 0 is less than or equal to 2. 0 is less than or equal to 2. Is that true or false? 0 is less than 2, so that is true. Because this point is true, it means this whole side will be true. So let me just shade in this side here. Okay, so the solution will be where these two overlap. Where will they overlap? Let's have a look. I'll do it in blue. Up here, it's only red. Down here, it's only green. In here is where it's red and green. This is where they overlap. So where it will overlap is on this solid line. Sorry about that. The whole thing moved. Let me try that again. Hit that button on the side of the pen. It really annoys me. That's really bad. Straight line down here. And it goes down and meets at that point there. Where else does it overlap? Well, this line is not included in the solution. It's because it was the scale down a bit. It's y greater than 2x plus 1. So this is not included in the solution, so we need to just keep that dotted line there. But everything in here is a solution, and so we can shade that whole area in there. That whole thing in there is the solution. And one thing in one of the last videos I forgot to say is that if you, it's often good if you want to, it's a bit confusing as to what the solution to the equation is. So if you do it in blue, then I'll just colour in blue and say equals R, which means region required. In other words, that's the solution there. That solution that I've coloured in blue is the region required. R is enough to say that. And so if you've got done it on pencil or something like that, and one region is like that, you've got sort of like that, and you've got another line going through like that, and you do it in that like perpendicular to that like that sort of thing. You could say if your region required, you could do a little box and do wherever it's crisscrossed like that, that's equal to the region required. That would be fine as well. And that's the only one I'm going to do on simultaneous linear inequalities. So what you do is you sketch one, then you sketch the other one. Basically, wherever they overlap is the solution to those two inequalities. And it has infinite solutions. There's many points in there that could be the answer to these two inequations. Have fun. Thank you.